Hello everyone. So my name is Saurabh Pant and I am from Sri Chaitanya Goshala campus. I happen to teach chemistry here. And up to till now we have discussed I think the electrochemistry part till the previous lectures. And I hope you understood the clear-cut knowledge about that. Now we are going to start from something totally different, which is the inorganic chemistry now. And if you have read in the junior inter properly, S block, boron family, carbon family, people are a little bit frightened about the inorganic part. I really don't know what the reason could be, but I seriously feel that if we deal this part properly, this inorganic part properly, in very logical manner, sir, logic can happen in this way. Yes, in this chapter also, if you enter the logic properly, you'll be able to understand the whole chapter in a very beautiful way. In fact, I feel the most beautiful thing in the whole chemistry lie in the blocks only, because if the blocks are properly understood, if the feelings properly come, it will help you in the organic as well as physical chemistry also. So let us start. For the next coming 9 lectures, I hope you'll be glued to your TV screens every day waiting for the lecture, because we are going to discuss one special trick in each and every lecture for the nitrogen and oxygen family. So let's start straight away. Now, the topic we have to start today is nitrogen and oxygen family. I know as per your track sheet, your nitrogen family is separate, oxygen family is separate, but I really would like to discuss both of them together so that a better feeling can come. Also, mugging, yes, there are a lot of mugging things in the inorganic part. I can't deny that fact. You have to mug up a lot of things, but my job is to make your mugging easy and to develop a little understanding so that most of the reactions, which are the major problem, you can understand better. So what I'm going to do here, one innovative way we will start the chapter with, we'll combine nitrogen and oxygen family physical and chemical properties together, so that not only you are prepared for these 2 chapters, you are also prepared for the NEET examination when they will ask you to compare the 2 groups easily. So let's start. Talking about the nitrogen family, let's understand both nitrogen and oxygen family, they come under the P block. Why they come under the P block? Because if we see their configurations, their valence shell configuration come as NS2. For example, nitrogen family comes as NS2, NP3, the valence shell configuration. For oxygen family, the valence shell configuration comes as NS2, NP4. So as the last electron enters into the P subshell in both the cases, that's why we call them the P block element. Which group are these from? Nitrogen family is from the 15th group in the periodic table, and oxygen family is from the 16th group in the periodic table. So basically, whenever the last electron enters into the P subshell, such kind of elements are known as P block elements, and the 2 groups we are going to discuss are 15th and 16th group. Which are the elements in this group here? So we have nitrogen, phosphorus, arsenic, antimony, bismuth. Unluckily for you, 2 years back NCERT have added one more element, moscovium. I always tell my students, qualify the NEET exam in the single attempt, because discoveries are happening every day, bhai sahab, and you never know one more element will be added later on. So right now moscovium is there, latest element, not there in the older NCERT. So make sure to remember this moscovium also. So let's understand nitrogen, phosphorus, arsenic, antimony, bismuth and moscovium. Talking about moscovium, atomic number 115, mass number 289, that is the molar mass is 289 gram per mole. It is a synthetic radioactive metal. That means we were fed up as human beings, we were fed up by studying all the well-known naturally occurring metals. People started making metals also and making your life a little tough for the NEET examination. So it is a synthetic radioactive metal. It was man-made, plus the configuration is same. The valence configuration is same as the remaining element, because nitrogen is 2nd period, this is 3rd period, this is 4th, 5th, 6th and 7th. It is from 7th period, that's why the configuration goes as 7s2, 7p3. So NS2, NP3, 7th period, 7s2, 7p3. This is just, this is not much important for you when the chemical property comes into play. So it's better to remember the configuration as it is. Now, it's a radioactive element. We don't have to study about its physical and chemical property, because again, luckily it is recently discovered. The studies are still going on. Talking about the oxygen family, that is the 16th group. We have oxygen, sulfur, selenium, tellurium, polonium, and the new element Lv, the love for this element named him as livermorium. Livermorium, atomic number 116, clear cut 115, 116, new element. Again, it is also synthetic radioactive element here. So it's a synthetic radioactive metal, mass number 292 gram per mole. This is the configuration, and configuration from the 7th period element will be exactly like NS2NP4. So it is 7S2 7P4. So these valence configurations are important majorly. Chaliye, so let's go ahead. How to remember this group? There are many ways of remembering. One small technique you can use, O se tipo. So O se tipo is one of the method you can remember the 16 group. How can you remember the nitrogen family? देखो भैया, न्यूजीलैंड, पाकिस्तान, ऑस्ट्रेलिया सब बिकारी. न्यूजीलैंड, पाकिस्तान, ऑस्ट्रेलिया सब बिकारी. So we can remember NPASSBBI, nitrogen, phosphorus, arsenic, antimony, bismuth. Talking about some of the periodic trends there here. As we go from top to bottom, the ionization enthalpy decreases. Question arises, sir, why the ionization enthalpy decrease? So let's understand. For example, we have this nucleus here, and as you are going down, let's say this is nitrogen and this is phosphorus. Because the size of phosphorus will be larger as you go from top to bottom. If this is nitrogen size, this is phosphorus. So the last electron in nitrogen is here, the last electron in phosphorus is here. So this is the nucleus. So as the electron is further away from the nucleus, it is easier to take the electron away. So what is ionization enthalpy? Ionization enthalpy is the energy required to eject the valence electron, to eject the last electron. So if I have to give energy here and here, so clear cut, because the electron is far away from the nucleus will not be able to attract electron as much. It will be easier to eject the electron here. So what happens here? As you go from top to bottom, the ionization enthalpy decreases. Why? Because the radius is increasing. Sir, why the radius is increasing? Because top to bottom, nitrogen was having a second shell as the last shell, second shell. Phosphorus have third shell as the last shell. So you can imagine if there is 1, 2, only 2 shell. Second case, there is 1, 2, 3 shells. So obviously person having 3 shell will be larger in size. His electron will be far away. So less energy is required to eject the electron there. So here we understand, top to bottom, radius increases, ionization enthalpy decreases. Luckily for us, in both the groups, radius increase, ionization enthalpy decreases. There is no exception as such. Same we go with the electronegativity here. Electronegativity also, top to bottom, decreases for the exact same reason. What is electronegativity? Tendency of attracting the shared pair of electron towards itself. So, if I have nucleus closer to the electron, I will be easily able to attract it. So, as you go top to bottom, size increases, the valence shell goes away from the nucleus, so the attraction of the bond pair also becomes tough. So ionization enthalpy usually vary hand in hand with the electronegativity, usually, but there are many exceptions. Luckily not here. So electronegativity decreases top to bottom in both the cases, just like the periodic table. Here one important thing is there, antimony and bismuth, it decreases. There is no problem, it decreases, but when you open the NCERT, you will find that antimony, bismuth both have same value in the Pauling scale of 1.9, 1.9. So what we have to say, if the question comes ki antimony, bismuth, they have same electronegativity, तो यार देखो भैया same cannot be there, but हाँ approximately same is there. So I will better write antimony more than equal to bismuth, that means approximately equal but not exactly equal. So variation is there. Going ahead, so radius we got in both cases, increases top to bottom, general trend. Ionization enthalpy decreases top to bottom, general trend. Electronegativity decreases top to bottom, general trend. Now what about the metallic character? So let us understand. Nitrogen, phosphorus are non-metal. Similarly, oxygen, sulfur are also non-metal. So the first two elements are non-metal in both cases. Next two are metalloid in both cases, and the last element in both cases are metal. So we can understand from non-metal via metalloid to metal. So what is metalloid? Metalloid means semi-metal, half behaving as a metal, half behaving as a little bit non-metal. So from non-metal to metal you are going, that means clear-cut metallic character is increasing in both the cases, no exception here we can say. So how easy it is to remember, you can see now. Otherwise what you people will do? You will mug up nitrogen family separately, oxygen family separately. So how you have to mug up together? Non-metal, metalloid, metals. So now let us start with the melting point and boiling point. Understand here, in both these groups, as top to bottom the size will increase. Understand one thing clearly, melting point, boiling point, both are related to the force of attraction. Melting point, boiling point, both of them are related to the force of attraction. And for both of them, you will be getting non-polar compounds here. Non-polar means what? Imagine if O combines with O. If O combines with O, is anyone more electronegative, anyone less electronegative? No, sir, they both are equally electronegative. So will anyone get a delta minus delta plus? No, sir. So both will get 0, 0 charge. Such kind of molecule are called non-polar. And for non-polar molecule, what we have to do? For non-polar molecules, your force of attraction depends upon size. Heavier the molecule, it's just like kind of gravity. Like Jupiter is big, so more gravity is there. In the same way, when the molecule is bigger in size, his force of attraction, which is known as van der Waals force of attraction, London dispersion force, which you read in the states of matter, that will also be more. So as the size increases, attraction increases for these two groups. So what we can say are, top to bottom, size increases, melting point, boiling point generally should increase. Again, exception will come. So bhaiya, exception here, we have to understand arsenic is the exception for melting point. So the melting point of arsenic is maximum. Whereas for the boiling point, antimony boiling point is maximum. What does it mean? It means that, this is antimony, this is bismuth. It means that for melting point increases up to arsenic. Yeah, arsenic bhai sahab has exceptionally high melting point, very high melting point. More than 1000 value we go. So arsenic melting point maximum, then antimony bismuth lesser. For bismuth, for this boiling point, up to antimony the boiling point increases, and for bismuth the boiling point is having a sharp decrease there. So you have to remember both of them separately. This diagram you can remember, very easy to remember this diagram. Just remember this tick like this. And for melting point, arsenic is the topmost, and for boiling point, antimony is the topmost. Simple trick to remember it. Coming here, luckily here melting point, boiling point both have the same order, and tellurium is the topper here. So how you can combine them and remember? See, I told you when you combine, it becomes always easier here. So when you have to remember boiling point for both of them, second last element maximum and last element a dip in both cases. Whereas melting point here also have the same order, but for nitrogen family, in the melting point, arsenic is exception. So for you, what you have to remember, arsenic for melting point is the topper. Otherwise, the second last element for boiling point here and for melting point, boiling point both here is the topper in both cases. The second last element means antimony here and tellurium here will be having the maximum melting point, boiling point here, tellurium. Antimony will have the maximum boiling point here. Going ahead, density. Luckily for us, in this case also, top to bottom density increases. Sir, why the density increases top to bottom? Any student can easily tell you that density is proportional to mass by volume. So what happens? The effect of mass you have to consider for both this group. It will be very easy for you to consider the answer. So top to bottom mass is increasing, density increases, volume you can ignore for both these groups. So bhaiya, density increases in both cases because mass increases, as simple as that. When it comes to allotropy, there is a little bit deviation in different textbooks. So whenever there is a difference in the textbook, one book is saying something else, the other is saying something else, always follow the Bible for NEET examination, that is the NCERT. So understand, NCERT says कि भैया nitrogen does not show allotropy. Nitrogen does not show allotropy as per the NCERT. So what we understand, everyone shows allotropy except nitrogen here. Whereas in the oxygen family, everyone shows allotropy, no exception there. So what we understood, ionization enthalpy, electronegativity, radius, melting point, boiling point. For boiling point, what's the trick? Second last element maximum. There melting point also second last element maximum. Here for melting point, arsenic maximum. Allotropy, nitrogen will not show. Everyone else in the 15 and 16 group total, everyone else will show. Now let us enter into very brilliant concept. Bhaiya, one of my favorite concepts here, radius and the case of melting point, boiling point, I will explain here. For a small tricky part is there, you are going to love it. So stay with me, very important part. So देखो यार, nitrogen to phosphorus, always remember one trick is there, that second period element are always exceptionally small. They are exceptionally small. So it is true that radius increases from top to bottom in both cases, it is 100% true, but that increase is considerably high when you come from second to third. Why sir third period element is very big क्या? नहीं, third, fourth, fifth, sixth period element, they are increasing in the size only, but nitrogen and oxygen, the second period element, sir, are they second period element? Yes sir, but they are the first element. How can they be second period element? Because the first period is of hydrogen and helium. So don't get confused there. The first period is hydrogen, helium. After that, if you see the periodic table, this is how the periodic table looks like. After that, after hydrogen, helium, second period we have nitrogen, oxygen. Third period element, second to third, there is a sudden jump in the radius. Sudden jump in the radius means considerable increase in the radius is there from nitrogen to phosphorus and oxygen to sulfur. Why? Because nitrogen and oxygen are exceptionally small in size. So the trick is second period element are exceptionally small. So we understand here that from nitrogen to phosphorus and oxygen to sulfur, the maximum increase in radius will happen. Direct question for the NEET examination, and bhaiya, needless to mention, extremely important. Next thing, melting point, boiling point, let's understand. So देखो यार, we know this thing also, melting point increases, boiling point increases, melting point increases, boiling point increases. Exception also, sir, we have mugged up. What else do you want from us to remember? I'll tell you. Keep calm. Understand N2 and P4 when we consider. Similarly, O2 and S8 when we consider. Here also, there is a considerable increase in melting point and boiling point. Sudden jump. Sudden. Wait here, you will understand better. Nitrogen, oxygen are gases, P4 and S8 are solid, bhai sahab. So sir, what is the problem? Problem is this, if top to bottom size increase, let's understand the logic. Top to bottom size increases. Size will increase, so force of attraction will increase. When the force of attraction is more, hai na, what will happen? The things will come together and become a solid. So what the logic should be, as you go from top to bottom, as the attraction is increasing, then the topmost element should be gaseous in the state and bottommost should be solid in the state. Why? Because the attraction is increasing top to bottom. So as the attraction increases, so bhaiya, more attraction at the bottom, solid will come, less attraction, gas will come. So in the middle, liquid should come na yaar. Gas have minimum attraction, solid have maximum attraction, so liquid should come in the middle. Understood bhai sahab? But nitrogen to phosphorus, nitrogen was a gas, phosphorus becomes solid. Oxygen to sulfur, oxygen was a gas, sulfur became solid. Arey bhaiya yaar, where the liquid went in the middle? That means sudden increase in the attraction is there. Here the attraction is very low, here the attraction is very high. Sir, what could be the reason? Let's think about it. Dekhe yaar, the reason, in simple words, if I say in single word how to remember, the reason is, single word reason I am writing here, the single word reason is atomicity yaar. Sir, what does it mean? Dekho, small nitrogen, small phosphorus atom. So phosphorus is a little bigger than nitrogen, accepted. But if it is a little bigger, then what will happen? Chalo, let's say considerable increase in size also. What will happen? Because phosphorus has a little larger size, extra force of attraction should come, but still it does not guarantee such a sudden increase in the boiling point and melting point. Very sudden increase is not expected there. Whereas, think about it, two lallu small nitrogen came together to form N2. Whereas, bigger 4 phosphorus atom came together to form P4. So one nitrogen was smaller than P, but 2 nitrogen atoms are much smaller than P4. Similarly, oxygen to lallu oxygen came together to make O2, whereas 8, are you able to understand? 8 sulfur atom came together to make acid. So bhaiya, acid size will be much bigger than oxygen size. So we have to understand, because the number of atoms in this molecule are much more, there is a very big size of P4 and acid. Because of that, there is a sudden very high increase in the melting point and boiling point. Because of that also we can say they are solid, they are gas. So I'll repeat it again. Nitrogen, oxygen diatomic, just 2 lallu atoms. P4 acid are polyatomic. That means bigger atom and number of atoms also are more. It contains double the atoms. It contains 4 times the atom. O2 acid 4 times the atom. That is why there is a sudden jump in the melting and the boiling point, and this is gas and suddenly this is solid. Now you will have the doubt in the head ki sir, still there is a problem ki why it forms only N2 and O2, why they form P4 and acid. For that we have another simple logic, another simple trick here. If you have read your boron carbon family properly, you would be knowing a small fact there that second period pi bonds are Baga-Manchi. Baga-Manchi pi bonds are made by the second period element. What does it mean? Understand, oxygen and nitrogen, they are professionals in making the pi bond, whereas sulfur and we can say the next element there, here phosphorus, they make Chadda pi bond. What is the meaning of this having Chadda pi bond and Manchi pi bond? Understand. Oxygen, bhai sahab, how many electrons are there in the last shell? 2 plus 4, 6 electrons are there. So if oxygen, bhai sahab, have 6 electrons in the last shell, nitrogen have how many? 3 plus 2, 5 electrons in the last shell. So how many electrons nitrogen need for the octet? 3, because 5 already are there. How many oxygen need for the octet? 2, because 6 are already there. So what to do here, yaar? Simple. Oxygen want to make 2 bonds to get the octet, because 6 plus 2, 8. Nitrogen want to make 3 bonds to get the octet, because 5 plus 3, 8. Now, to make 2 bonds, you need to make 1 sigma and 1 pi. To make 3 bonds, you need to make 1 sigma and 2 pi. And bhaiya, as soon as sulfur and phosphorus listen to it, ki bhaiya, we have to make pi bond, they start crying. Why? Because we very well know they make very Chadda pi bond. So what happens? This S2, this P4, they become highly unstable. P2. Why? Because if you expect phosphorus to make P2, this poor fellow has to make 2 pi bond. Bhaiya, he can't think about it. Similarly, when you want to make S2, these 2 sulfur atoms will have to make 1 pi bond, and they make Chadda pi bond. So what they do, they rather take another approach, like P4 exists like this. Here what happens, you can see each phosphorus is making 3 bonds, but all 3 are sigma. So why sigma? Because he make Chadda pi bond, na yaar. Because only second period element make Manchi pi bond. Whereas what sulfur does, I think you know very well, sulfur is a very small atom here, but he arranged in the crown-like structure like this. For example, we can say in this way. So what we can say, 1, 2, 3, 4, 5, 6, 7, 8. In this way, each sulfur makes 2 bonds, but both are sigma. So to avoid making pi bond, they have to make sigma bond. So they have to combine with more and more atoms so that they get completed octet. And because they can't make pi bond, so they cannot make diatomic molecule like O2, N2. That's why oxygen exists like O2, nitrogen like N2, whereas phosphorus has to exist like P4, and acid, because of which their sizes of the molecule, P4 is very big. Not S, S8 is very big. As a result, there is a sudden jump in the melting point, boiling point, and they exist as a solid. So this was about the basic idea. So let us carry on. So now, let us talk about the inert pair effect. Maybe you remember a little bit this name from your junior inter time also. So as per the inert pair effect, understand there are always going to be firstly 2 different oxidation states. Think in this way, 15 group is NS2 NP3 configuration. If only NP electron goes out, which oxidation state you will get? Only NP electrons are involved in the bonding. So plus 3 will come because there are 3 electrons. Similarly, if only NP4 are involved in the bonding for the oxygen family, 16 group, the configuration is NS2 NP4. Only NP electrons involved, you will get plus 4 oxidation state. So I'm calling it lower oxidation state when only the NP electrons are involved. Similarly, when both NS and NP get involved, so 3 plus 2 total plus 5 oxidation state will come. Here 2 plus 4 total plus 6 oxidation state will come. So what we understand, there are at least 2 different oxidation states you are going to get. One is the lower, one is the higher. Lower is shown when only NP are involved in the bonding. Higher is shown when NS, NP both are involved in the bonding. Top to bottom, as we go, what happens? This NS2 start becoming little bit inert. He is not interested for the bonding as we are going down the group. So what happens here? As you go top to bottom, this NP3 are more and more involved in the bonding. So plus 3 stability increases. Here plus 4 stability increases. As well as NS2 is becoming less and less interested in the bonding. It is becoming inert and inert pair. So what will happen? Plus 5 stability decreases top to bottom, and plus 6 stability decreases here top to bottom. So bhaiya, what happens? Top to bottom plus 3 stability increases, plus 4 increases for 15 and 16 group respectively, plus 5 and plus 6 decreases for 15 16 group respectively. One more important thing here, nitrogen family can show -3 oxidation state, -3 charge also it can show. Oxygen family shows -2 oxidation state. Why, sir? Why is it possible? Understand very simple here. When oxygen family is there, it will have 6 electrons in the last shell, 2 more required for bonding, so -2. Nitrogen family, 5 electrons in the last shell, 3 more required for bonding, so -3. But we have to understand negative oxidation state is shown by non-metals. So we have to understand here top to bottom when we go, metallic character increases. So bhaiya, obviously -3, -2 tendency will decrease because metals love to show positive charge. Think of any metal like lithium. Have you ever imagined lithium minus? No, na yaar, because metals love plus. So as you go from top to bottom, metallic character increase, so tendency of showing negative oxidation state decreases. One more thing, regarding occurrence, I told you, for occurrence, read it from the NCERT, and which kind of question they can ask you, like for example, sulfur is present in which cases? So protein, garlic, onion, mustard, hair, wool. I'll tell you a very nice idea to understand how and where the sulfur is present. Remaining occurrence you will read, sulfur I will teach you how you have to understand. So dekho yaar, your hair contains sulfur. So anything which is good for your hair will be containing sulfur also. So think in this way yaar. Very simple. When I was having a little bit like hair were falling at that time, I was about to become batta tala. So someone told me apply onion, eat garlic, apply mustard oil. The protein in the hair is less, so use some protein serum. All those things contain sulfur. And obviously our hair contains sulfur. Wool contains sulfur. Ha yaar, hair of sheep also is hair only na yaar. Hair of sheep is wool. So wool also contain sulfur. So how to remember? Hair and good things for hair, all of them they contain sulfur. Talking about nitrogen, oxygen, their maximum covalency is 4. That means they can make maximum 4 bonds. Why? They are in second period. So they have 2s and 2p orbitals. So bhaiya, 2s, 2p, total orbitals are 4. So in total 4 bonds only they can make maximum. High electronegativity they have. As a result, they can show hydrogen bonding. Water and ammonia, they show hydrogen bonding. And electronegativity of oxygen is more than nitrogen. They also make stable pi bonds because they are second period element. As a result, nitrogen makes N2 molecule. We discussed in the beginning of the lecture also. And this is pseudo-inert gas. So what is the meaning of pseudo-inert gas? This is highly unreactive because to make him react, you have to break this bond. And to break this bond, this much energy will be required. Apart from that, if someone asks you N2P2, who is more stable? Obviously N2. Why? Because pi bond manchi. O2S2, who is more stable? Obviously O2. Why? Because pi bond manchi. But if single bond of nitrogen and single bond of oxygen is less stable than single bond of phosphorus. Why? Because they are small in size, so repulsion will be more. So what will happen? Because of the small size, more repulsion, it becomes easy to break their bond. Phosphorus and sulfur, they are big in size, so their lone pairs are far away, so the repulsions will be less. So bhaiya, that's why phosphorus sulfur has more tendency to combine with each other, that is catenation property. So phosphorus sulfur has more catenation than oxygen and nitrogen. So this was the first lecture from the 15-16 group combined. In this lecture we learnt about the physical and chemical properties of nitrogen and oxygen family. One assignment I gave you to read, that is the occurrence of nitrogen oxygen family members. Sulfur I told about, that it is found in the hair and the hair related product like onion, garlic, but believe it me or not, my hair were falling and I tried to use onion. It did not work much. Anyway, so in the next part of the video, I'll be talking about some more chemical properties like reactions with hydrogen, oxygen, etc., etc. And we'll be going into details of nitrogen family thereafter. So that is all from my side today. Stay healthy, stay safe. Thank you.